Hey guys, Joe back once again with some OCR FSMQ lessons, and today we have the second part of linear programming. Now, the learning objective is simply to improve an understanding of the world of linear programming. Now, if you haven't seen the first part, that was released a couple of days ago, so go and check that out. But it's a long-winded question, that one, and for this PowerPoint I think I cut things down a little bit and colour-coded it a little bit more just so that you guys can try and get your head around it. But let's get into the lesson. So here's another question in the world of linear programming. Most of them are context based, but in the exam, if you're lucky, you'll just be given the inequalities and have to plot them and then maximize, minimize. But here we go. An oil company has two refineries. Refinery 1 produces 100 barrels of high grade oil, 200 barrels of medium grade, and 300 barrels of low grade oil. It costs 10,000 per day to operate. Now, Refinery 2 produces 200 barrels of high grade, 100 barrels of medium grade, and 200 barrels of low grade, and it costs 9,000 per day to operate that one. An order is taken by the oil company to provide 2,000 barrels of high grade oil, 2,000 barrels of medium grade, and 3,600 barrels of low grade. How many days should the company operate each factory in order to minimize costs? So I think last lesson we did something, we're maximizing the number of chairs and tables that were made. This time we're minimizing costs as much as possible. Now then, let X be the number of days Refinery 1 operates, and let Y be the number of days Refinery 2 operates. Simple so far. High grade oil produced, so I think it said there's 100, hold on, let's have a look. It can produce 100 barrels of high grade oil, and Refinery 2 does 200 barrels of high grade oil, so that's where that comes from, and that must be greater than or equal to 2,000, because if we look back here, the oil company needs to provide 2,000 barrels of high grade oil. So similarly, it's looking like we're going to have 200 plus 100 must be greater than or equal to 2,000. So let's check that now. Obviously that inequality here will cancel down to this one. So just make sure that your equations, or inequalities I should say, are in the simplest form possible. So there we go, 200x plus 100y is greater than or equal to 2,000, which cancels down to that. And the low grade oil produced is that as well, and that cancels down nicely to 3x plus 2y must be greater than or equal to 36. So let's, pardon me about that, sorry. We obviously can't operate the factory for a negative number of days, so x is always greater than or equal to 0, and y is always greater than or equal to 0. The cost of running the refineries for this time is 10,000, because if you remember, it was 10,000 per day for Refinery 1 and 9,000 per day for Refinery 2. So we want to minimise that as much as possible and keep the costs down. So there's our lovely grid, already scaled for you. That's what it'll usually be in an exam. I don't think I've seen ones where you have to come up with your own scale, but you know, trial and error will get you there. So there's our inequalities, and if we do the cover-up method, now I wonder if we can cover it with anything. I'm not really sure, to be honest, but I'm trying loads of things here. Should have really done this beforehand, but if we cover up the 2y, we've got x equals 20, so we'll put an, oops, sorry about that, I'll get rid of that now. Sorry about this, guys. So we'll put an x on 20. And if you cover up the x, you get 2y equals 20, so y must equal 10. Same with this one. If you cover up the y, you get 2x equals 20, so x must equal 10, like that. And if you cover up the 2x, you get y equals 20, so up there like that, and so on and so on. So there's that line, this one here, and that's 2x plus 2y equals 20. There's that one. That's x plus 2y equals 20. And there's 3x plus 2y equals 36. Now then, let's think about the inequalities. We'll want to be above the line, so we're going to shade under in all three instances like that. Now then, our answer lies somewhere in this R region here. we call that R, obviously, and I think that's going to pop up any second now, is it? There we go. There's R. So there you go. There's with 4 possible points then, and we want the least amount. And by eye, you would probably say that one, but we need to check this using our objective function. So remember, 10,000x plus 9,000y equals your cost, and you can, times divide that down so that. Well, hold on. Actually, you don't have to do that. Scratch that. We think of a number that is kind to both of these numbers here. So I'm probably thinking times them together you get 90,000. So let's say 10,000x plus 9,000y equals 90,000. And we draw it on like that using the cover up method. If 10,000x equals 90,000, then x must equal 9. We put a cross there. And if 9,000y equals 90,000, y must equal 10, so we put cross there. Then we draw an objective function, and remember we want to go in a parallel fashion closest to home, so closest to the corner, because it's minimizing, so you don't want to get into the white zone at all. So minimize costs, so we want the first time the dotted line moves in a parallel style into the R zone. So there you go, and it was in fact that point. So this is our minimum point here, and it looks to me it's about 8, 6, but we want to check this using algebra, so we solve it simultaneously. So x plus 2y equals 20. Remember, that's why we label the lines, so that we know which lines we're setting equal to each other. And 3x plus 2y equals 36. You don't have to set them equal to each other, but I solve them simultaneously, so I've got matched middles here, so I can take them away from each other, top from bottom. So it's going to be 3x minus x is 2x, 36 minus 20 is 16, x equals 8. And put that back in, and you get a y of 6. So I was right, it is right on the line, and you could risk it in an exam. You might well get lovely answers, and in this case you do, but always check that algebra. So x equals 8, and y equals 6. So open refinery 1 for 8 days, and refinery 2 for 6 days. And remember to put that back through the cost function to get the total amount of money that the company will be spending. There you go. Total cost is 80,000 plus 54,000, which is £134,000 over the 14 days in total that they're open. So yeah, it's that's pretty much it, and that's the end of this lesson. It's just another example. Last lesson we looked at maximising costs. Today we're looking at minimising. Apologies for a few mistakes I've made during the commentary, but this is all totally live. So yeah, apologies about that. But in the next part we will be doing another example of linear programming and talking about something called integer solutions. So I hope you guys have enjoyed. Please leave a like if it has helped you. Certainly good for me to know. I'll answer any of your questions down below in the comments section, and of course there's a worksheet always linked in the description. So yeah, hopefully you guys found it helpful, and I shall see you next time for some more linear programming. Bye guys.